Lesson 7.1 talks about graphing systems of linear equations. Now, there are 3 lessons in Chapter 7 that we're going to learn. Lesson 7.1, 7.2, and 7.3. They are all 3 different methods to do the exact same thing, okay? The whole time we're trying to solve systems of equations. Now, what a system means is it means that there's more than one. So we're going to be working with 2 equations. When you get into Algebra 2, you'll start working with 3 equations, okay? But for now, we're just going to work for 2 equations, and we're going to try to find the ordered pair that makes both of them have the same solution, okay? So 7.1, we're going to learn the graphing method. In 7.2, we're doing the exact same thing, but we are using the substitution method. 7.3, we're doing the exact same thing, but we're using the elimination method, okay? So 3 different ways to do the same thing. So let me give you a little bit of background information. You don't need to write this down. I'm just going to talk through it. An equation with an x and a y is called a linear equation because it makes a line. Anytime you have an x and y, think about your coordinate plane. You have an x-axis and a y-axis. We make a line if I have an equation that has those, okay? X comma y represents a point on the graph, okay? So if I gave you 2 comma 4, we would go to the right 2, up 4, and that is a point on the graph. We can plug a point into any linear equation. Let's say, like, if you have 2x plus 6y equals 18, okay? And I said, here's the point, 3, 2. Let's see if this is going to be a solution. So because this is x and because this is y, I know I can take out the x and plug in a 3. And I can take out the y and I can plug in a 2 and check to see if it all works out, okay? So when you have a system, that means I'm not only just going to have 2x plus 6y equals 18. I'm going to have another equation, maybe like 4x minus 7y equals 28, okay? Something like that. Now, this is a system because there are 2 equations. So the whole point of 7.1, 7.2, 7.3 is to find, I like to call it the magical ordered pair that I can plug into both of these equations and get a solution for both of them, okay? So the graphing method. First of all, before we do that, we're going to plug this in and we're going to say, yes, it is a solution to the system, or no, it's not. The system acts as 1. So if it's a solution to one but not the other, your answer is no. It's not a solution to the system. It's a solution to one of the equations, but not to the system. So if it's no to the first one, do you think we even really need to solve the second one? No, because we know it's going to be no, okay? So let's look at this first equation. 3x minus 2y equals 11. And then the second equation is negative x plus 6y equals 7. First of all, they give us the ordered pair, 5, 2. Which one of these numbers is x and which one is y? 5 is x and 2 is y. Perfect. So what I'm going to do is I'm going to do one at a time, and I'm going to plug them into each equation. So I'm going to start with the first one, 3, and I'm going to take out the x, and I'm going to plug in a 5, minus 2, take out the y, plug in a 2, equals 11. So basically all I'm doing is I'm solving this side of the equation to see if it matches 11. So what's 3 times 5? 15. Negative 2 times 2 is minus 4. 15 minus 4 is 11 equals 11. So I know that that point is a solution to the first equation. But I can't just stop and say, yeah, it's a solution to the system, because I don't know if it's a solution to the second one. So I do the same thing. So I have negative, and you could write the 1 there out in front of the x if you wanted to. I'm going to do that. Then I'm going to take out the x, and I'm going to plug in a 5, plus 6, and I'm going to plug in a 2, equals 7. Negative 1 times 5 is negative 5, plus 12, equals 7. Negative 5 plus 12 is 7. So I know that this ordered pair is the solution to the system. Okay? So my answer is yes, because when I plugged it in, it checks out for both of them. That is what we are going to be doing today, is they're not going to give us the ordered pair. We are going to have to look for the ordered pair by this today's lesson is graphing, so we can find out which one is a solution to both. So I want you guys to do this second one on your own. Okay, Stephen. So tell me what you plugged in where. What did your first equation look like when you plugged in the numbers?
1 times 3 plus 3 over 6 equals 15.
Perfect. Okay. So we solve the left side to see if it matches the right. So we get 3 minus 18 equals 15. Well, what's 3 minus 18? So does negative 15 equal positive 15? No. So here's my question to you. I know that it's already no to the first equation. So does that mean it's going to be a solution to the system? No. So do I really even need to plug it into the second one? No, because what's that going to do? It's either going to tell us yes, but it still doesn't matter because our answer is going to have to be no, or it's going to tell us no again, and we already know that it's no. So we can just stop there and say no. It's not a solution to the system. Okay, if you were to get yes for the first one, then obviously you do have to plug it into the second one because the second one could be no. It may not always be yes. All right? So that's how we're going to plug in a point and we're going to check it. So let me give you a little more background. Again, you don't have to write this down right now. Actually, you know what? It might be a good idea to write this down. Point of intersection. Who can give me just like a broad definition of what an intersection is? Where things cross. A road has an intersection. Lines have an intersection. It's where the two lines cross. Okay? So what I know is if I graph those lines, where they meet or where they cross, that is their common or shared point. That means that point is the solution. Okay? So, I know that in this graph right here, my x value is what? For where they cross, I'm sorry. My x value is going to be 2, and my y value is going to be -1. So, the ordered pair that is a solution to both of those equations is 2, -1. All I have to do is look at where they cross, and I know that's the solution. Now, there is a way to check it, and so we would do exactly what we just did in the last example. Plug in 2 for x and -1 for y, and solve to see if it works out for both of them. Okay? That's a good idea to do when they don't already give you the graph. Or maybe you're not 100% positive that you always write the points right. Maybe you said, oh, I thought it was going to be -1, 2. Well, you did the y instead of the x. So you would want to plug it in and check it. Okay? So where the lines cross, that's where we can find that ordered pair that is a solution to both. Say, well, that's good to know. So let's look. They gave us a graph. Now, this would be something that they've given to you on the test, on the quiz, in the book for homework. So the graph's already drawn. All they want you to do is use your eyeballs and tell me where the solution is. There's no work to be done at all. So we know the solution is where? Where the two lines cross. So let's find where the two lines cross, which is right here. So I can draw a line straight up and run into the x value. What's the x value? 3. And I can draw a line straight across and run into the y value. And what is it? -3. So 3, -3 is the solution to both of the lines. Now you say, do we need to plug it in and check? Yeah, let's go ahead and do that. It will not be required of you on the test and quiz. I'm just going to do it so you can know how to check if you want to. But it's not going to be required. Okay, so I'm going to plug in -3 equals 3 times 3 minus 12. Negative 3 equals 9 minus 12. Negative 3 equals negative 3. So I know it works out for the first one. So let's try the second one. Negative 3 equals negative 2 times 3 plus 3. Negative 3 equals negative 6 plus 3. Negative 3 equals negative 3. Yep, so I know for a fact I've got the right ordered pair. Okay, so that's how you would check your work. So let's take a step farther with the next equation, or next example, and they're going to ask us to find the solution. Well, what's missing in this problem that we had in the last one? The graph. So guess what? You have to graph it. We learned in chapter 5 there is a certain form that lines have to be in order to graph them. What is that form? Rise over run is the slope. What is it? Y equals mx plus b. Very good. Y equals mx plus b. So our equations have to be in this form before I can graph them. Okay? So let's look at the first equation right here. X plus y equals negative 2. Is that in slope-intercept form? No. So I want to get the y by itself, which means I need to do what to the x? Subtract it. And I'm just going to write minus 1x. And I move it over to this side. And the first equation is y equals negative 1x minus 2. So I've got that one. I'm not going to graph it yet. I'm going to go ahead and put the second one in slope-intercept form, and then I'll graph it together. Okay? So the second equation, what do I need to do first? I want to get y by itself. So what should I do to the 2x? Subtract 2x. Very good. So it cancels out. Move it over here. And I'm left with negative 3y is equal to negative 2x minus 9. Now what do? Divide by negative 3. Okay. Y equals, what happens to the negative 2 over the negative 3? Become a positive. Positive 2 over 3x. What happens to negative 9 divided by negative 3? Positive 3. Okay? So this is my new equation. So I'm going to write it underneath the first one just so we see both of the equations together. You say, wait a second, how in the world am I going to graph a fraction? What's that fraction? Slope, which is rise over run. So that actually works out perfectly. You don't have to graph a fraction. So now this is where we get out our graph paper. Now you say, before we started, I told you guys that you had to graph on graph paper. And the reason why is because if you try to graph on your piece of notebook paper, and you don't draw the line perfectly straight, guess what's going to happen? Those lines are going to intersect at another point, and that's not going to be right. So we have to use graph paper. We want to use some sort of straight edge to draw our lines, or we could put more points, which I'm going to show you. Okay? So let's get out our graph paper. I'm going to set up my graph here for a second. Okay, so I've got my graph made now. And in order to graph these equations, there are two things that I have to know about these two equations. For slope, excuse me, for slope-intercept form, what are they? This is pulling back from 2 chapters ago. You need the y-intercept. Very good. That's our b. So what's the b of the first equation? Negative 2, and we also need our slope, or our m, negative 1. Now let's write that in rise over run form. What's negative 1 in rise over run? Negative 1 over positive 1. So let's graph this equation. Where am I going to go first? Down 2, very good, because I want to go to negative 2 on the y-axis. And then from there, I'm going to use my rise over run. Well, my rise is negative 1. So am I going to go up 1 or down 1? Down 1. And then my run is positive 1. So I'm going to go to the right one, which is right here. Now, this line is just 2 points. It's not very big. So what I want to do is I want to keep using my slope to place more points, because the more points I have, the straighter my line will be and the longer it will be, so it'll be easier to find the solution. So I'm going to keep going from this point. Down 1 over 1. Then again, down 1 over 1. Down 1 over 1. Down 1 over 1. See how my line is nice and long for one side? But what about the other side? Okay? Let's think about it. Could I reverse my slope and go up 1 and over to the negative side? Would that still be on the same line? Yep. So I'm going to go up 1 to the left 1. Up 1, left 1. Just like that. Okay, so that's how you make a nice long line. And we're going to draw a line through it. That way it's going to be really easy to figure out exactly where our two lines cross. So that's my first line. So let's graph the second line. What is the m of the second equation? The m is 2 over 3. And what's the b? 3. Okay? So where am I going to go first? Up 3 and place my point. And then I'm going to go up 2, because it's positive 2, over positive 3. So 1, 2, 3. Now, our graph's not very big, so if I tried to do another point, I probably really wouldn't be able to see it. So let's go the opposite direction. Could I go down 2 and over to the negative 3? Because a double negative, doesn't it still make a positive? Yep. So I'm going to go down 2 over 3. Okay. Is somebody seeing where our lines are crossing? Right here is where our two lines intersect. At that point. So that was the whole point, is to graph those to find that intersection. So that is our answer. What is that ordered pair from that point right there? Negative 3, 1. And that's the ordered pair. That is the solution to the equation. Now, in order to double check and make sure you got it right, you could plug it into both equations. I'm not going to take the time to do that since I showed you how to do it on the next one. But you can do that to make sure that you got the answer right. Okay? Okay, so let's practice this one more time. Here's our next equation. This graph's going to be a little bit bigger than the other one. Okay? So 3x plus y equals 11. What do I need to do first? Can I graph this line just like it is? Get y equals mx plus b, which means I need to get this y by itself. So I subtract 3x on both sides. And I get y is equal to negative 3x plus 11. Then on the next problem, I want to get this y by itself. So what do I need to do to move the x over? Subtract it. So now I have negative 2y is equal to negative 1x plus 6. Then we divide by negative 2 everywhere. And y equals positive 1/2 x minus 3. So again, I'm going to write it up here at the top so we can see our two lines. And now it's time to get out my graph so I can actually graph them. Now remember, our y-intercept of the first equation is going to be 11. So your graph is going to need to be much bigger than our one was last time. Okay, so let's graph this. So first of all, let's find the m and the b of each equation. What is the m of the first equation? Negative 3 over 1, because we're going to do our rise over run. What is our b of the first equation? 11. Okay, so let's find that on our graph, and let's plot that first. So I'm going to go up to positive 11, place my point, and then where am I going to go? Down 3, so 1, 2, 3, and then over positive 1. Now, I'm going to keep doing that because my line is going to be very short at the top, and I need to keep going and going. So I'm going to go down 3 over 1. Down 3 over 1. Down 3 over 1. Okay? I'm going to draw my line through those points. So the next equation. What is the m of this equation? 1/2. What is the b of this equation? -3. So where am I going to go first? Down 3. And then I'm going to go up 1 over 2. Up 1 over 2. Oh, ding, ding, ding. Have I found the place where they're going to intersect? So I'm just going to draw my line through. Make sure you always draw your line through. And you don't have to keep drawing points once you find out where they intersect. Okay? So where is that magical ordered pair? +4, -1. So your answer should always be an ordered pair on these type of problems. Okay, so that's how we solve systems of equations, meaning two equations, using the graphing method. Tomorrow we'll learn a different method. So we're going to be doing the same thing, but doing a different way to find it. Okay, here is the homework that you have for tonight. I want you to go ahead and begin on that.